All right, in here we are going to go over example 1 in section 4.5. And in this, we are actually going to work with solving and finding solutions and zeros of higher degree polynomials. So now, as you guys know, in order to solve a polynomial, we have to go ahead and find the x values for that'll solve the problem of setting our polynomial equal to 0. Now, we've worked with these all throughout this year. So some of these, I'm not going to go back and review how to solve every single type of polynomial. If factoring and solving a problem like this is still a challenge, then I would recommend going back to some previous sections and work on factoring before coming back to look at this. Now, as with any type of polynomial or factoring, when we go ahead and try to do that, the first thing we always want to do is see if all of our terms have a factor that we can take out of here. That's called our greatest common factor, or GCF. When we look at this, we see that all of our terms or coefficients can be divided by 2, and all of our terms also have an x in them. So we can take out a common solution, a common factor of 2x, and we're left with x squared minus 6x plus 9. Now, this should look pretty familiar to you. This trinomial in here is just a perfect square trinomial. And when we go ahead and factor this again, we just get our original GCF, 2x, times x minus 3 squared. Again, when we factor x squared minus 6x plus 9, we're just left with x minus 3 times x minus 3. Now, when we solve for 0, we go ahead and we set each of our terms equal to 0. So we're going to have 2x, our first term, equal to 0, and we're going to keep x3 squared as our second term and set that equal to 0. Now, when we go ahead and solve each of these, I want to take a little time to focus on our second term of x minus 3 squared equal to 0. Now, if we write out x minus 3 squared, that just looks like x minus 3 times x minus 3. Now, you'll remember, just like we did with 2x, when we go ahead and solve one of these polynomials equal to 0, we actually break down our expression into all of the simplified binomials and set each one equal to 0. So right now, if we take each of these binomials and set them equal to 0, you'll see that we're going to get x equals to 3 right here and x equals to 3 in our second. This is what we call a repeated solution right here. Our solutions, again, are x equals 0, x equals 3, and x equals 3. So it's repeated twice. Now, normally, our solutions, or roots, are the x-intercepts of the graph. I'm going to show you something interesting that happens here when we have a repeated solution of a graph. So again, keep in mind that our solution right here, when we get x equals 3, this solution is actually a repeated solution. Excuse me. So I want to go ahead real quick and show you what this graph looks like. A little graphing image comes up right here, but I want to go ahead and show you on Desmos so we can get a closer look at this. So again, if you look at these intercepts, you'll see that x equals 0, which was our first solution, shows up, and of course our graph crosses the x-axis at x equals 0. Now, when we look a little closer at x equals 3, which was our repeated solution, we see that our graph right here comes down and touches the x-axis at x equals 3, but it never quite touches it. So again, it touches the x-axis, but never quite goes through it. So if we, again, we come back and look at this, we'll notice that we've got one of our solutions where it goes through the x-axis and another of ours where it just touches that. Now, we've got when we've got a repeated solution right here, we've got a couple properties that, that we can learn about repeated solutions. So one rule that I want to tell you is that when we have a repeated solution, so in this case we had x minus 3 squared, which means that we're going to have x equals 3 repeated twice. So when a factor, right here, when a factor is raised to an even power, like ours was, we're going to have our graph just touch the x-axis, but not crossing it, like this one right here. We had x minus 3 squared, which was an even power, so our graph is going to come down, touch the x-axis, and come back up. Now, if we had x minus 3 to an odd power, so for example, if this was x minus 3 to the third power, which is an odd power, we're going to have our graph come down and actually cross the axis at our solution or our root. So if x minus 3 was raised to an odd power, our graph would actually cross through. Instead of touching at x equals 3, it would cross through at x equals 3. So slight difference between our repeated solutions right here. Okay, so we're going to see that a little bit more throughout this chapter. So please keep that in mind.